everyone, today I will explain the CCNA LAB question to you. Let's take a look at this question. So, the meaning of this question is to tell us its core objective is to have us work on these two switches, SW1 and SW2. But between these two, a compliant aggregated link needs to be established here using LACP, which is a public protocol. And this link, well, it has several. There are a few requirements that must be met. One requirement is that LACP must be used. It's written here, right? And in addition, the switches must be connected in series and able to communicate with each other. Right? As we mentioned before, Cisco believes that the connection between switches should be traditional and also using the 802.1q encapsulation. In other words, this command, this configuration command uses this .1q, which is IEEE 802.1. 802.1q, the standard. Right? A dot just simply means a single point, right? Okay, so let's look at this configuration command. Actually, it has several requirements. Here's a list of requirements. There are three, right? Three requirements. The idea is to set up a port channel, and you must use LACP with a specific number, right? Number 44, correct? And here it says you must use the 802.1q tagging. All right, let's look directly at the configuration. For example, this. Let's take this one as an example. First, we configure these two interfaces together, right? Interfaces 0-0 and 0-1, and then add them to an aggregation group. According to the requirements, the aggregation group must be 44, right? 44, and then I use this active mode. This way, if both sides are set to active, they'll negotiate automatically, or if one side is set to passive, it will also negotiate automatically, right? But if both sides are set to force mode, in that mode, there won't be any negotiation, right? The negotiation just won't happen. Oh, but if both sides are set to force, it can still be established successfully. However, if it's passive, then it can't be established. All right, then let's enter this aggregation interface to configure its link, just like we did earlier. These two steps have already been completed. Here, we've created an aggregation interface, and this aggregation interface has included these two physical interfaces. In other words, it can manage these two interfaces, right? All the data will go through this interface after it arrives. As for whether it forms load balancing or how many packets are sent from each side, that can be configured later on. Anyway, these two interfaces are already managed by this aggregation interface, right? All the traffic goes through this aggregation. So next we need to perform a series of configurations on this aggregation interface, which is what this section of configuration is about. How many positions are there? Then first, according to the requirements, let it be able to handle this VLAN tag, right? So it can process tag data frames, then later on configure its link as a trunk, right? The link mode changes to trunk, and then, according to the requirements, set the local VLAN as this 7746 local VLAN and the 7462 side both need to be configured the same, right? If you want to change it, you have to change both sides to be the same. You can't have this side as 746 and the other side still as 1. That would be wrong, right? If you want to change both sides, make them the same. And the configuration below is exactly the same. Finally, just set this interface to no shutdown. Then it will come up, right? Right? It's the same below. For the switch SW2 below, you also configure two interfaces and then create this aggregated interface to manage these two physical interfaces, right? All the data goes through this aggregated interface. So you follow the same process below. Follow this label. According to this requirement, the group number is 44. Then enter this interface and configure the trunk link, right? And that's it. This is very simple.